Now let's talk about radiation sterilization, a non-thermal technique for sterilizing products and medical devices. There are three methods used to achieve this: gamma radiation, electron beam, or ultraviolet light. Gamma radiation is the most penetrative and effective radiation method to kill microorganisms. It uses gamma rays coming from radioisotope cobalt-60 or cesium-137. They are electromagnetic waves with very high energy and very short wavelengths. These energetic photons are able to destroy nucleic acids of microorganisms and disrupt their DNA. Gamma sterilization is usually the method of choice with a reference absorbed dose of not less than 25 kg. There is ISO 11137, which supports gamma sterilization. This standard describes the approach to validating the process with a dose to achieve a defined sterility assurance level. So, what are the benefits of gamma radiation? The first benefit is that it is safe, reliable, and highly effective. It has good penetration of dense materials with density over 0.4 grams per cubic centimeter. It penetrates medical devices and pharmaceutical products while sealed in their final packaging. It's compatible with most plastic materials. And after radiation, sterility is ensured during the distribution process by maintaining the same packaging used during radiation. It is possible to control gamma radiation by using a dosimeter. A dosimeter measures how much energy a product absorbs. It ensures that the sterilization dose matches the maximum permissible dose determined during validation within a process load. The turnaround time for gamma radiation sterilization depends on the product, the absorbed dose of radiation, the type, and the size of the product. The sterilization of surgical instruments requires a lower absorbed dose of radiation and can have a turnaround time of a few hours. The sterilization of larger products, such as medical devices, may require a higher absorbed dose of radiation and have a longer turnaround time of several days. Overall, gamma radiation sterilization is a relatively fast process compared to other sterilization methods, such as heat sterilization, which can take several hours or even days. And it's a relatively safe and effective method for sterilizing a wide range of products. Electron beams are high-energy ionizing radiations of beta particles coming from a source of radioactive element, such as strontium-90. As they are not electromagnetic waves like gamma radiation, electron beams are less penetrative. They are accelerated mechanically to near the speed of light, reaching extremely high energy levels in the range of 5 to 30 kg. Now let's see the meaning of kg. It is the unit of measurement for the absorbed dose of ionizing radiation. A kg is the amount of radiation energy absorbed per unit of mass. The absorbed dose is the amount of energy deposited in the product being irradiated. Electron beam radiation can be used for sterilizing medical devices, medical supplies, equipment, and medicinal products. What are the benefits of electron beam radiation? Well, it's an effective sterilization process that can eliminate a wide range of microorganisms, including bacteria, viruses, and spores. Plus, it is a fast and efficient method of sterilization. The process is able to sterilize large quantities of products in a relatively short amount of time. The speed protects the product's material properties, prevents polymer degradation, and causes no damage to sterile seals on product packaging. It's a safe process. It does not use chemicals, so there is no risk of chemical residue remaining on the product. It reduces the oxidative damage to the product irradiated and avoids a color change in polymers present in packaging or medical devices. And it can penetrate a variety of materials, including foils. However, it has some disadvantages. The equipment and installation is expensive, and there is the risk of radiolytic byproduct formation like hydroxy radicals that could cause damage to raw materials and some drug substances. Ultraviolet light is considered a surface sterilizing method only, as its energy level is insufficient to penetrate materials. It is effective if the light contacts the target microorganisms at a sufficient intensity for a sufficient time. However, it has no effects on shadow, and its intensity is reduced by the square of the distance from the source and by particulates which are in the ray path. UV light can potentially damage the eyes, so special protection needs to be taken. The use of protective goggles or safety glasses with UV-absorbing lenses can help to shield the eyes from these rays. One of the most common types of UV light to help reduce the spread of microorganisms and infections in surfaces with low bioburden is UVC light. UVC light has a wavelength of between 200 and 280 nanometers, which is able to damage the DNA and RNA of microorganisms, making it difficult for them to reproduce and survive. It is used to sterilize surfaces and air in hospitals and laboratories. UVC light can also be used to purify water and air in places where clean water and air are essential, such as in pharmaceutical plants and in HVAC systems. That's all for this session on the sterilization methods of heat, radiation, and electron beam. I hope you found it illuminating. At the Scilife Academy, we're always thinking about how to support your educational journey into quality, so hope to see you soon for another session.